Les participants sont en mode écoute seule.
Hello, welcome to Forsk webinar. My name is Vincent Spiegel. I'm Forsk Head of Sales. I'm pleased to host you on this webinar. Today's topic is using Atoll for planning small cells. Atoll is used worldwide to plan the regular outdoor cellular networks, and as the mobile operators are now looking into the small cell solutions with a strong interest, we wanted to give you the opportunity to see how this can be handled in Atoll and what benefits you can gain from our tools in this domain. For this, after my introduction, Edward Relin, who is product manager at Forsk, will show you what the Atoll software offers to address the challenges of small cells planning. During this webinar, you will be muted, but you can send us your questions through the GoToWebinar window. We will answer your questions at the end of the webinar in a Q&A session. So here is the agenda of today's session. I will give you a short update about our company profile and product offering before the presentation of Edward. Edward will introduce the challenges of the small cell solutions before listing the requirements it puts on the planning and optimization tools. Finally, we will see how Atoll addresses them in a combination of slides and demonstrations shown by Edward before answering your questions. So I will start now with updating you about Forsk and Atoll. So Forsk is a software company, a leader of the radio planning and optimization software market. It is a company with its main offices in France, USA and China, supported by a worldwide network of distributors. We lead the market in Europe, Asia-Pac and in the USA, with revenues of around 18 million euros, so $24 million, and 6,000 active Atoll users. Most of these users are working for operators, as 300 operators use Atoll worldwide. Atoll is a multi-technology tool, which is not only a planning platform for cellular and microwave transmission networks, but it carries also several optimization modules, such as the ACP, the ASP, which stands for Automatic Site Positioning, and the AFP, as well as a module dedicated to backhaul capacity planning. Atoll is based on a native 64-bit architecture, which enables you to handle a large amount of data with a full single RAN multi-route model, enabling planning, HEPNet and small cells network in common simulation processes. Finally, Atoll offers inbuilt capabilities, allowing automation of the planning and optimization processes. One of the key modules offered within the Atoll software suite is the ACP. ACP standing for Automatic Cell Planning. This module, available for all cellular technologies, is capable of managing multi-layer and cross-technology optimization tasks, where in one same simultaneous run, a multi-route network including GSM, UMTS, LTE, or CDMA and LTE cells will be optimized. The ACP is fully embedded in the Atoll software, allowing optimization and planning in the same workspace, streamlining the engineering processes significantly by avoiding having to manage data exchanges between various pieces of software. The main purpose of the ACP is to simultaneously optimize the existing infrastructure by changing cell and antenna parameters, and to help select sites among a list of candidates to commission or to decommission, with the goal of operating a more cost-efficient network. These two features are really key for the rollout of small cells. Used properly, it will allow the operators to choose in a very efficient manner which locations are offering the best overall throughput to their subscribers. After this introduction, I will now leave you with Edward Relin, who will go into depth of how Atoll can address the challenges of the introduction of small cells And I will then come back as a moderator for the questions and answer session at the end of this presentation. So Edward, I will now give you the lead on the webinar, and I will come back later.
Thank you, Vincent. Hello, everybody, and thank you for joining our webinar. Today, I'll be presenting how Atoll can help planning small cells. Currently, we're witnessing an exponential growth of mobile users, and most importantly, the increase in the number of smartphones. The new smartphone models, coupled with new and higher quality applications, backed by new technologies such as AGSPA and LTE, drive the traffic demand uphill exponentially. Many analysts in the industry have predicted a tremendous traffic increase in the coming years. At one point or another, this is bound to become a critical issue. The network operators need to address it now, before their network will start experiencing extreme stress caused by data-hungry applications and the danger of their competitors winning a bigger part of market share. So the question is, how can we satisfy the huge traffic demand? What could be the solution to this problem? Well, as always, it seems there will be several solutions, and the small cells might be just one of them. How can we deal with this massive traffic demand? Add new sites, but what about interference? The challenge is how to increase the number of sites, but not the interference level. Well, small cells look like to be a solution for this, and well, the industry is predicting massive deployment of small cells in high traffic areas. By 2018, analysts say some 11 million small cells will be in use. The biggest operators are seriously considering deploying small cells. 9 out of 10 of biggest operators have started small cell deployments. A big number of small cells implies even a bigger number of small cell candidates. Well, let's see what site candidates could look like in a planning tool. Right, so here I have an Atoll project of a multi-technology GSM UMTS LT network. And to this network, I would, well, during our presentation, I'll add a new layer of small cells. In order to add this new layer of small cells, I'll be using a list of site candidates. So let me show you how those site candidates are presented in the map. You can see, well, it's a fairly dense small cell candidate list. So it can get quite big. So the tool has to handle these seamlessly. Well, I'll try to lay down the essential requirements for small cell deployment. Well, first of all, a planning tool is a must. Moreover, the planning tool should support certain mandatory features. Various technologies need to be properly modeled. That gives the possibility to weight different options for future network evolution. The tool should support multi-technology small cells in a combined LTE, AGSPA, CDMA, Wi-Fi modeling. The advanced features should be implemented in order to make the most of the current advancements in the mobile technologies. High accuracy requires a significant volume of data to be processed and used for calculations. We need to work with high-resolution geographic data, vast amounts of network information, and big number of network elements. The calculation engine should have high performance to provide the required analysis results in a reasonable time. Only a 64-bit native platform can handle this flawlessly. Let me briefly show you the types of the geodata, the resolution, well, just to give you an idea about what could be used for small cell planning. I'll just hide for the moment my small cell candidates. in my mobile network. Right. Okay, so let's have a brief look on the geodata. So first of all, we'll start with DTM. So in this particular example, I have a DTM of 2 meters resolution. Then on top of it, I have added a clutter class layer. So the most precise layer is 2 meters. I'll just zoom in a bit so you can see how detailed is this clutter map. And on top of it, I can use also building information, which is, well, quite an important requirement if you want to plan a new small cell layer. So the building information can be used either in raster format or in vector format. Let's take a look at how small cells are rolled out using Atoll features. First of all, the small cell planning requires a multi-technology approach. The existing technologies also need to be accounted for in the possible deployment scenarios. Atoll allows you to evaluate different deployment strategies: in-carrier, dedicated carrier, or separate zone deployments. While deploying a small cell layer, we can choose to optimize these existing networks for better overall network quality. The 64-bit engine will help you recreate the complex mobile network environment with high accuracy. Advanced features can be tried to estimate the value added in terms of final capacity and quality improvement. Well, for example, CRAN architecture can be combined with carrier aggregation, as well as enhanced IC and cell reselection algorithms for interference mitigation and further network capacity increase. The traffic demand and the backhaul availability can be also included in the optimization process. Small cells planning requires high-resolution data and accurate propagation models. We provide urban propagation models to help you predict the radio wave propagation in dense urban environments. The traffic information is essential to deploying small cells. Atoll can combine several traffic maps from various sources to help finding the best site locations. The line network traffic, the population maps, as well as social media maps can be used for selecting new site candidates. Atoll can help to define multiple objectives based on quality and traffic. These can be applied to all technologies for an overall quality and capacity improvement. We have developed a small cell planning feature to automate, centralize, and steer the site deployment with small cell requirements in mind. So let me show you the small cell planning, small cell selection actually. It's called small cell selection. So this small cell selection feature actually takes into account the existing sites, new site candidates. You can define low spectral efficiency areas or any other user-defined areas as well. You can use high accuracy traffic maps, and the tool will, well, Atoll actually will help you to select and to identify the backhaul availability. So you can use, for example, fiber lines or, well, copper lines in order to identify the site candidates which can be connected to the internet, or you can calculate the line of sight and non-line of sight microwave links in order to connect your site candidates. In order to adapt your different site types to, well, any particular ready environment, Atoll will allow you to select site templates. Small cells can be installed in many places. That means that the best sites should be selected from a very large number of site candidates. In the example that I'm going to show you, we have used about 84,000 site candidates. So let me show you my site candidate list in the ACP setup. Right, so just open my ACP setup. So here they are, 84,000, about 84,000 site candidates. You can look into more details. Right, so different site candidates which can be used for, well, which I will be using for my exercise, small cell deployment in this particular network. Well, those site candidates can be well, analyzed on the map. You can have, for example, a closer look. Let me show it to you. Right. So, for example, if I'll select one particular site and I want to have a panoramic view, we have a small tool which will help you doing that. So this tool actually will open the candidate site location, so you can get a better view of this candidate. So you can, well, you can see where potential site locations could be. Okay. Well, small cells can be installed on lampposts, traffic lights, bus stops, train stations, well, and other locations. There are several constraints related to site selection. The limited footprint of small cells require precise location to efficiently capture the traffic. So high accuracy traffic maps are required to find the best location. You have to have a backhaul available in order to connect those site candidates, either fiber, cable, wireless backhaul, line of sight, and non-line of sight. So the small cells are small and do not cover large areas. So the margin for error is limited. Finding the right location is tremendously important. How can we find out where the existing and future subscribers will be located? Well, the combination of live network traffic map, marketing data, population map, and, for example, social media data can help us make a fairly good estimate of the traffic demand. Well, let's see how to use traffic maps in Atoll. Right. Okay. Let me just zoom out a bit so you'll get a better view of my traffic maps. So in terms of traffic maps, you can use well, usual environment-based traffic maps using user profiles. You can use user density traffic maps. You can combine several types of traffic maps. You can include, for example, the population data, right? So in case you have fairly accurate population data, then you can use them in traffic map generation. For this particular example, I have also used tweets. Well, those tweets actually been captured from the Twitter API. So we ran it for about 1 week. So those tweets, well, they can be used actually to create a heat map. Let me display you the heat map. So this heat map has been generated using Atoll. So this heat map actually helps you well, estimating a new site position, right? So you can see, so the heat map basically it's a representation of point density and point location on the map. Okay. In a city, there are many obstacles hindering the radio wave propagation. In order to find the best fit, we need to consider different site configurations. For example, omni-sites can be used in open areas like squares, parks. Dual sector sites will better propagate along the street. Actually, we can give Atoll the flexibility to select the best site configuration for a given location. The new sites need a backhaul to connect to the core network, to share the signaling information, and to carry the traffic. Several backhaul options could be available. You can have direct access via copper lines or even better fiber. But when there are no such connectivity options available, then we need to look at a wireless backhaul. The two types can be considered, line of sight and non-line of sight. These mostly depends on the frequency band. Lower frequencies tend to be used for non-line of sight and higher frequencies for line of sight. However, there are studies showing that higher frequency bands could be also used for near line of sight links. In order to take into account the availability and the type of the backhaul, so Atoll help you identify and rank the sites which can be connected to the backhaul. Right. So in my particular example, I have used fiber lines, and using those fiber lines, Atoll has created a site class. So actually, I have sites that can be connected to the fiber, and well, the criteria is for the site is to be within a certain distance from the fiber line, which is user definable. With regards to the rest of the sites, Atoll helped me to calculate line of sight from my macro network to my site candidates. So you'll see my green dots over here. They are easily connectable in using a line of sight backhaul, microwave. Sorry. For the rest of the sites, which are not in the line of sight, well, they have been identified as non-line of sight site candidates. As you can see, in dense urban area, I'll have more non-line of sight site candidates, and in the open areas, I have line of sight site candidates. Well, you can go even further and evaluate what value added could bring you the new features. The assessment can be made for the potential capacity and quality increase. C-RAN architecture can be modeled using a common scheduler with the remote radio units. Atoll supports advanced layering features allowing for traffic steering, priority, and mobility management. Dedicated carrier small cell deployment using carrier aggregation with the macrosites will increase the peak rates. Enhanced ICIC will alleviate the interference increase due to in-carrier small cell deployment. As soon as the new sites are selected, you can run the Atoll automatic allocation features to assign neighbors, PCIs, and RSIs. Let's take a look at the resulting throughput map that I have obtained after my small cell deployment. As you can clearly see, my small cell layer brought a significant improvement to the capacity and to the quality of my network. Let's review this scenario in Atoll. So I have started with my small cell candidates, then I have used small cell selection feature, defining, well, the technologies that I would like. I have asked Atoll to deploy a small cell layer for my LT technology. You can use other technologies if you like, for UMTS, for example. Then I have included my potential small cell site locations. I have identified areas where I would like to deploy my small cells. For example, I have identified the low spectral efficiency areas. So the tool will try to place the new sites in a low spectrum efficiency areas. Then I have defined my site templates, right? So for different environment, Atoll will select me the best site template. Then I have used my traffic maps, including the heat maps based on tweets, and the total accumulated traffic based on live traffic and population data. Then on this section, I have defined the fiber lines. So I have included in the calculation process the fiber lines. So the tool has selected me the site candidates within a certain distance from fiber line. Then for those sites which cannot be connected to the fiber lines, or well for copper lines as well, Atoll helped me to calculate the line of sight to site candidates from my macro layer, and for the rest of them the non-line of sight. All right. So the resulting network, let me show it to you. I'll display my sites and my LTE network. Like you can see, it's a fairly dense network. Right. So those are my small cells deployed in this particular scenario. And just to have, well, a rough idea about the quality improvement, I can display the throughput map before and after the small cell deployment. For example, I can select areas, and I just can analyze to see the throughput improvement. Right. So, for example, in this particular case, I have an improvement from 3 megabits per second to 50 megabits per second. Well, this network and resulting coverage can be displayed in 3D using Google Earth. Well, as you know, we have a export to Google Earth add-in, which allows you to export this information to Google Earth. Okay, so for a 3D view, you can use Google Earth with your new network and new throughput map. On this slide, I have the resulting CDF of throughput in terms of covered area. So Atoll allowed me to compare the throughput before and after small cell deployment. So higher audio modulation and coding schemes could now be used with our small cell layer to improve local and overall throughput. So we can conclude that Atoll platform fully models small cells and allows various deployment aspects to be taken into account for an accurate and efficient network planning. Well, this brings us to the end of my presentation, but before this I would like to give you just a few highlights related to planning small cells using our software products. Atoll provides advanced multi-technology features for planning small cells. Atoll's 64-bit platform supports large number of sites, huge amounts of data and maps, and accurate calculations. Atoll offers the best-in-class LTE advanced features to integrate small cells within complex radio networks and diverse environments. So at this point, we'll switch to our Q&A session, and I will hand it over to Vincent for any eventual question that you might have during the presentation. Vincent, please.
Thank you, Edward, for the presentation. We have many people connected on the webinar, and questions are starting to flow in. First, a very simple question is, you have shown in this presentation several features that allow to plan small cells, and the audience wonders which features are now fully available in Atoll 3.2, and if they are not available, what is the roadmap of release of these features? Can you tell us more about this?
Actually, most of the small cell planning features are already available in the current Atoll version. What we have added, it's the small cell selection features, which have been centralized in one dialog, which helps you to do it in a quick and efficient manner. We have made some improvement to the ACP in order to take into account in a more detailed manner the small cells. So actually you can already plan small cells using our existing features. But if you'd like to have a more centralized, more convenient way of planning small cells, then you will need to use our small cell selection features.
Okay, thank you, Edward, for this answer. You have shown most of the features in a GSM, UMTS, LTE network, and as we have many customers coming in from American markets and around, we wonder if the features that you have shown are also available for CDMA and LTE.
Well, as you know, we have mainly two types of multi-technology projects. We have 3GPP oriented project type, which contains GSM, UMTS, and LTE technologies. But the second project type is 3GPP2 oriented, which models CDMA 2000 and LTE. Well, please note that both project types, they can also use Wi-Fi for eventual traffic offloading. So you'll find it exactly the same features in 3GPP2 and 3GPP project types.
Okay, and can you also put out what features you have shown require an ACP license?
The small cell selection features, actually they drive the ACP, and they provide the configuration information to the ACP in order to select new site candidates. So if you would like Atoll to help you to select the best site candidates automatically, using the criteria that I have listed during my presentation, then you'll need the license, the ACP license.
Okay, Edward, and can you tell us more about the indoor features regarding small cells that we can have in Atoll 3.2? And when I say indoor, of course, I mean also in building, and maybe we should explain the difference between the two concepts.
All right. So actually we draw a line between two indoor planning aspects. So there is an indoor planning and in-building planning. So what we call indoor planning is actually fully covered by existing Atoll features. So in this particular case, you can plan outdoor sites and the propagation indoors, and you can also plan indoor sites and calculate the propagation indoors and outdoors. This modeling is based on the building shape, actually, and on the propagation loss due to exterior walls. Whereas in building planning, it's much more detailed planning, where you normally will take into account the interior walls, the loss due to propagation between floors, and for these type of planning, our customers usually they have deployed third-party solutions. So if we speak about indoor planning, Atoll can do it. If you want to have an in-building planning, then you'll need a third-party tool, which is actually can be easily interfaced with Atoll, and you can work from Atoll with this third-party tool.
And we have questions about the source of your social media map. How can we know if the people who are in this tweet heat map are subscribers of the network we are managing? And then a second question which is related is how do we load this tweet traffic maps into Atoll, and who does this? Does Twitter send the information, or does Atoll collect it? Can you explain this, please?
Well, I'll start from the second question about how we have collected those data. So those data are made available by Twitter. Actually, Twitter provides an open API, and we have used this open API to collect the Twitter information. So those well, points on the map, they are real tweets generated by Twitter users. Actually, we have a script which have been running for 1 week collecting all these tweets. So the information which is included in those tweets, I don't think they will allow you to distinguish between different network operators or between different networks. There are certain type of information like type of mobile telephone used or type of the OS used. There are, well, geographical, so the location information which have been geolocated using the application on the mobile phone. So, well, those tweets actually, I think in combination with live traffic data and with combination of population data, can help you identify the new site locations. So basically those tweets, they have been served by some network, and for example, if you'll compare the coverage map or the service area with those tweets, and then if you see that you are not providing enough service to these particular areas, so obviously those tweets have been served by your competitor. So you might be interested in considering installing a site to serve those tweets or those areas.
Okay, so we have a question regarding which deals with nominal plans. So when we have a required offload on an area, how can we figure out how many small cells we should have in this area?
The amount of traffic that will be offloaded to your small cell area depends on many criteria. So first of all, where your small cells will be located. Then what type of features will be used for those small cells. Are you planning to do a in-carrier small cell deployment? Then you need to consider the enhanced ICIC and cell range expansions. If it's, well, a separate carrier deployment, then you might consider using carrier aggregation. So there are many variables in this exercise. So you need to carefully plan, and you need a tool to use to model this traffic flow, and only then you can judge how much traffic you can offload to your small cell layer.
Okay. You have shown how small cells are connected to the backhaul, or criteria of connection to the backhaul. So can we have actually show the best link between the small cell and the transport layer in Atoll?
All right. Well, I'm not sure what you call the best link, but well, I'll explain you my example. So in my example, the best or the highest priority link is the fiber, right? So let me show you how the ACP takes this into account. Right. So we do it using site classes, and those site classes, they are customizable. So in my example, I have used 3 site classes, and I have defined different costs per site class. So for the ACP, it's cheaper to install or to use a site which has a fiber connectivity. If you would like to model backhaul and to see the backhaul capacity and to analyze it, you can also use our backhaul capacity planning module. And using this module, you can display on the map the links between the sites and the core network. So actually you can see the transport layer. Not only see, but analyze it as well.
We have a question related to interferences, and at the beginning of the presentation you talk about the interferences and what are the tools we have to avoid interferences, or what is available in the technology to avoid interferences.
In order to mitigate the interference levels in Atoll, you have several tools. So first of all, for small cells, dedicated to small cell, you have the enhanced ICIC. You can also do the automatic PCI planning, the RSI planning. You can play with your range cell expansion in order to find a good trade-off between the captured traffic and interference level.
Yes, okay, so Edward, we receive other questions that I'm currently reading. Sorry for the time for processing. A question about the accuracy of, I suppose, the propagation model when we use 3D vectors instead of clutter height. That's not really exactly related to small cells. It's more a generic question about propagation models. So can you tell us a bit more about this?
Well, the building information provided in a vector format, it's the closest to the reality. When you use a raster format, a certain degree of rasterization or pixelization will be done. So you'll have stairs like buildings. Well, the accuracy, it's difficult to say. You need to do measurements and compare and to see if, because, well, theoretically speaking, the vector information will provide you more accuracy. But, well, you need to compare the cost and the accuracy in order to see if it's worth paying more for more precise data and how much does it cost. So sometimes if you can get the vector information data with no big difference, with a small difference compared to raster information, then it's preferable to use vector data. And if we speak about the propagation models, the vector information sometimes give you more features in terms of propagation modeling. For example, Crosswave will use vector information in order to model the canyoning effect, and it can be done using only vector information.
Okay, and Edward, can you explain, maybe explain again how the traffic load is taken into account in the ACP optimization in the case of small cells?
When you deploy a new small cell layer, so when you deploy new small cells, the ACP will take into account the standard load for those small cells. It will take into account actual load from your macro layer, but for the small cells it will be a standard load which will allow you to calculate an average level of interference and consequently to calculate the throughput that can be provided by the small cells.
Okay, I'm afraid we have to end the session here, even though if we cannot answer all the questions, some of them will be taken offline as the time of the webinar is limited. So we will gather the questions and answer them a bit later. So I would like to thank you again for your attendance to this webinar. You have my email address in this slide and Edward's email address on this slide. So if you have further questions that you didn't have the time to ask us during this webinar, you can use these email addresses to send them. We might also forward them to our colleagues in the who are dealing with your accounts. So thank you again. Hope to see you soon in another webinar or in another FOSC event. And have a nice day or a nice evening, depending where you're located. Thank you. Bye-bye.
Thank you.